Good evening.
Hello, good evening, everyone. Can everyone hear me?
Yes, sir.
Okay. Ritam, Pruta, Shamili, Shubhangi, Samragni, are you people
Yes,
able to hear me?
yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
Okay. So let us start. Last day I had given some homework questions. Okay. So let us start, everyone. Can you people see my screen?
Yes, sir.
Okay. Okay. So this is your PDF. Okay, let's see. What have we discussed last day? Okay, these were the things we have discussed. Okay. So everyone, I'm writing down the answers. If you have any doubt, let me know. First one is D. Everyone has got option D. Tell me. Number one is option D. Hello, good evening, Joyatra. Can you hear me?
Yes, sir.
Joyatra, you didn't send me your homework. What happened?
Sir, I had an exam today, so I couldn't send. I will send it by today.
Okay. Your exam in school,
No, sir, mock test.
mock test.
Yeah, test series like in coaching.
You could have done it at least. Okay, but
Yes.
send it by tomorrow or tonight.
Okay, okay, sir.
Okay. Question number two. The answer is option B.
Sir, can I please solve the number one?
Number one. Okay, let us start.
Sir, can you solve number 2?
Okay. But you have done it, right?
I didn't get the answer.
You got what is the value of alpha you have got? Tell me.
Minus 96. No, no, sir. Minus 48.
Oh, minus 48.
Yes,
Acha.
sir.
And beta?
Beta, I got 36.
Okay, okay. Acha, wait, then let me solve.
Sir,
You are
show
making
me
a
the
mistake with
calculation error.
you have made a mistake in alpha, finding alpha. I saw your process and gave you correct. Okay, just check whether you are making a calculation mistake or not. Okay, I'm solving number one. Okay, pay attention. So first of all, I'm going to solve Sn. Sn. Okay, so what is Sn? Sn is equal to Sn is equal to 1 minus q to the power n upon 1 minus q. Right, tell me. Shwankit, are you getting?
Yes, sir.
Okay, next. Hello, good evening, Orip. Can you hear me?
Yes, sir.
Orip, you didn't send me your homework.
Sir, last class I was not present, sir. I'll try to send it by tomorrow.
But I gave the video also, right? I have given the recording, isn't it?
Yes, sir. I've seen the recording.
So you should have sent it if you have seen the recording. Hmm?
Yes, sir. I'll send it by tomorrow.
But why not today? What happened?
But tomorrow I have exam.
You have exams tomorrow. Which exam?
Sir, physics.
Final exam.
Yes, sir.
Okay. Send it to me by tomorrow after your exam.
Okay, sir.
Hello, Abhigyan, are you there?
Yes, sir.
Abhigyan, you didn't send me your homework?
Yes, sir. I know. Actually, I am going to be regular after.
You have one?
I'm going to be regular after that.
Oh, you want to be regular after today, right? But before this, you didn't
I had
want to
exam.
be
I had exam.
that exam. So let's see. Acha, anyways, pay attention. There are actually n plus 1 terms, right? Tell me, Shwankit, there are n plus 1 terms. So can I write S is equal to q to the power n plus 1 upon minus 1 upon q minus 1? Tell me. Right, Shwankit?
Yes, sir.
And what is Tn then? Tn will be equal to q plus 1 by 2 whole to the power n plus 1 minus 1 upon q plus 1 by 2 minus 1. Can you understand?
Yes, sir.
Okay. Then over here, let us multiply by 2 to the power n plus 1 in the numerator and denominator. What are we getting? We are going to get q plus 1 whole to the power n plus 1 minus 2 to the power n plus 1 divided by q plus 1. Wait a minute. It is q plus 1 minus 2. So q minus 1 into 2 to the power n plus 2 to the power n. Tell me. Right. Are you able to understand, Shwankit, up to this much?
Yes, sir.
Next. The series we have got 101 C1 plus 101 C2 into S1.
Multiply 2 to the power n plus 1 in numerator denominator.
Yes. Have you understood? When you multiply by 2 to the power n plus 1 in the numerator and denominator, over here we'll get q plus 1 whole to the power n plus 1.
Yes, sir.
Over here minus 2 to the power n plus 1.
Yes, sir.
In the denominator, we have got q minus 1 by 2. When you multiply by 2 to the power n plus 1, you are going to get q minus 1 into 2 to the power n.
You have solved it and then multiplied. Yes, sir. Got it.
Yes, yes, yes. After simplification, I have multiplied. Tell me, is it clear?
Yes, sir.
Next, I'm going to look at the series now. So series is 101 C1 plus 101 C2 into S1 plus 101 C3. I think it is S2 then. 101 C3 into S2 plus dot 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 S2 plus dot 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 101 C1 into S100. Okay, this is given as alpha into t to the power 100. So let us first of all simplify this one. Okay, let's see what are we getting. So we are getting 101 C1 plus 101 C2 into S1. S1 is basically S1 will be equal to, Acha, this is actually Sn. So S1 will be equal to q square minus 1 upon q minus 1. Right, tell me. Q square minus 1 upon q minus 1. So similarly, Shwankit, tell me what will be S2. Shwankit, tell me what will be S2.
So I'm telling that wouldn't the last term be 101 C 101?
Ah, yes, yes. Quickly tell me what will be S2. I've got
Yes, Q,
uh,
Q minus 1 by Q
q,
minus 1.
exactly, q cube minus 1 upon q minus 1 plus dot 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 101 c 100 into q to the power
101 minus 1 by Q
101.
minus.
Exactly. Q to the power 101 minus 1 upon q minus 1. So I'm going to take 1 by q minus 1 common. Within brackets, we are going to get 101 C1 into q minus 1 plus 101 C2 into q square minus 1 plus dot 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 plus 101 C101 into q to the power 101 minus 1 Okay. Are you getting Shavankit?
Yes, sir.
Now what I'm going to do is I'm going to separate. Okay, I'm going to separate the variables. I mean, separate the series. Basically, over here we have got 101 C1 into Q, then 101 C2 into Q square, then 101 C3 into Q cube, up to 101 C1 into Q to the power 101. Are you getting?
Yes, sir.
So, Shavankit, when over here in the first series, you are going to get 101 C1 into Q plus 101 C2 into Q square plus dot 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 plus 101 C 101 into Q to the power 101. Okay, minus in this bracket, we are going to get 101 C1 plus 101 C2 plus dot 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 plus 101 C1. So Shavankit, quickly tell me what is the sum of the first series?
The sum of the first series.
Yes. Are
So
you
it
able to
would be
relate it with
yes,
1
sir, in
plus
the
x
GP.
whole to... No, no, they are in GP. How?
Oh no, sir. Not GP.
They are similar to 1 plus x whole to the power n. You are able to relate? Tell me.
Yes, sir.
Okay. So basically, this will become 1 plus q
Cube
whole to the
power n.
power 101. But over here, 101 C0 is missing, right?
Yes, sir.
So I'm going to subtract 1. Minus over here. This is the sum of the binomial coefficient. But again, 101 C0 is missing, right? So I'm going to
So it
write
is
it as
about 1.
101 minus 1. Right. Acha, from both of them, 1 will get cancelled, right?
Yes, sir.
So finally we are going to get 1 upon q minus 1 into 1 plus q whole to the power 101 minus 2 to the power 101. Tell me. Okay. And this is given as, this must be given as something. Alpha into T100. Okay. So let's substitute what is T100. T100 will be equal to alpha into T100. T100 will be equal to Q plus 1 whole to the power n plus 1. 100. Okay. So see, this kind of questions can come in mains. Okay. So T100 will be equal to Q plus 1 whole to the power 101 minus 2 to the power 101 divided by Q minus 1 over here 2 to the power 100. So can you see that this term and this whole thing gets cancelled? Right, tell me, Shwankit.
Yes.
Okay, so what is the value of alpha? Alpha is equal to 2 to the power 100. Tell me, Shwankit, is it clear?
Yes, sir. Clear.
Okay, so hence the answer is option number D. Next, I'll move on to question number 2. Okay, Adrija, you got your stick
Yes,
or
sir,
should I?
I got the answer.
Okay, so I'm not solving this one. Anyone having any doubt in number 2? Then I'll solve it. 2 is option B. Number 3, proof problem. Anyone having any doubt? Number 3, anyone having any doubt? Proof problem. Number 4.
Sir.
4 is also a proof problem. Anyone having any doubt, you can ask me. Number 5 is very easy. 5 is option C. Anyone having any doubt, you can ask me now. Number 5 is option C.
Can you
6
solve
is
question number 5?
5. Okay,
Yes.
so pay attention. Okay, so for number 5, I can do it by binomial, without binomial also. So tell me. Achha, I'll tell you 2, 3 methods. Number 5. Method 1. using binomial, okay? So 15 to the power 23, can I write it as 19 minus 4 whole to the power 23? Tell me. This will be equal to whole to the power 23. 19 minus 4 whole to the power 23. So this will be equal to 23C0 into 19 to the power 23 plus, sorry, minus 23C1 19 to the power 22 into 4 to the power 1 plus 23C2 into 19 to the power 21 and 4 squared. Okay. Minus dot 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 dot. Last term will be positive or negative? Tell me. Last term is 23C23.
Positive.
20C3, 23. It will be negative. Okay. 4 to the power 23. Okay. And then what is 19 plus 4 whole to the power 23? All of them positive, right?
Yes,
23C0.
sir.
19 to the power 23 plus 23C1. 19 to the power 22 into 4 plus dot 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 dot. Like this it goes on. Last one will also be plus. So when you add, all the odd power terms will get cancelled. Okay. You're going to get 2 into 23C0, that is 19 to the power 23 plus 23C2 into 19 to the power 21 into 4 squared plus dot 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 dot. Lastly, you are going to get 23C22. What do you think? Is it divisible by 19? Tell me. This is divisible by 19.
Yes, sir.
So hence the answer is option C.
Okay, sir.
Okay. Next. Method 2. If you remember, x to the power n plus y to the power n is divisible by x plus y,
And n is odd.
for n belongs to odd natural numbers. Right? You know this,
Yes, sir.
Avipsha? Like whenever n is odd, x to the power n plus y to the power n is equal to x plus y into x to the power n minus 1 into y. Sorry, x to the power n minus 1 plus minus x to the power n minus 2 into y plus x to the power n minus 3 into y squared minus dot 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 dot. Lastly will be plus y to the power n minus 1. Are you getting, Avipsha?
Yes, sir.
Okay. And for your reference, I'm writing x to the power n minus y to the power n also. It is x minus y into x to the power n minus 1 plus x to the power n minus 2 into y plus x to the power n minus 3 into y squared. Okay, this we have done it in basic maths in the first chapter. Anyways, so over here, since 23 is odd, can I say that 15 to the power 23 plus 23 to the power 23 is divisible by 15 plus 23, which is 38. This implies 15 to the power 23 plus 23 to the power 23 is divisible by 19. Is it clear?
Yes, sir.
Okay. Okay, anyone having any doubt in number 6? Number 7 is 70. If there's anyone having any doubt, you can ask me now. Hello, good evening, Shashwato. Can you hear me?
Yes, sir. I actually had another tuition before this, and there was a lot of traffic jam today. A wedding is like going on in front of our house. That's why.
Oh, okay. And Shashwato, what about the homework? Tell me.
It's
There was
actually
no traffic
consecutive
jam over
exam.
there.
No, it's actually consecutive exams are going on. That's why I couldn't send.
Okay. School exam.
Yes, sir.
When will it end?
Sir, by 28th.
Oh, acha, yes, you told. Okay. And number 8 is 105. So anyone having any doubt? Tell me. Anyone having any doubt? 7, 8. Okay. Then we can move on. Last day we have done until this one. Find the number of ways in which 30 marks can be allotted to 8 questions. Okay, we can do some more problems. Okay. So Shashwato, since you are not sending the homework after your exam ends, send me all the homeworks at once. Okay.
No, sir, I will send it tomorrow only.
Tomorrow only. Okay.
So actually, 3 consecutive exams are going on. That's why I couldn't send it.
Okay.
Our next exam is 3 days later, so I can send it now.
Okay then. Question number 1 for today. Find the number of ways. Find the number of ways to select. Okay, just give me 1 minute, everyone. Find the number of ways to select. Copy. Yes. Find the number of ways to select 5 letters. 5 letters from the letters of the word. From the letters of the word independence. Last day we have done generating functions. Everyone applied today. Find the number of ways to select 5 letters from the letters of the word independence. Okay, solve. Once you have done it, send your answers. Question number 2. Find the number of ways to select 5 letters from 5 A's, 4 B's, and 3 C's. Solve. Question number 3. Prove that prove that 72C36 minus 1 is divisible by 73. Once you have done it, quickly send your answers. So everyone, should I start with the first one? Number of ways to select?
Wait for 2 minutes.
Okay, send. Rashishwari, check your answer again. Ahir, right answer. Oriv, check your answer again. Okay, so Rashishwari, did you go through the last class's video?
No, sir, I'm still out of station. I will return tomorrow. After that, I'm going to check it.
Okay. Samragni, check your answer again. Adrito, check your answer again. Shamali, check your answer again. Hey, just remember generating functions. Apply, everyone. Adrija, check your answer again. Okay, Rashashri, now it is correct. Adrito, now it is correct. Okay, let us start. Independence. We need to understand how many alike letters are there, and then we can formulate. Then we can create the generating functions. Okay. Then we can create the generating function for it. Okay. Aisha, there's a slight mistake. Check it again. So everyone, I is repeated how many times? Okay, I is only once, I guess. N is there how many times?
3.
Three
Sir, I've
times.
sent it.
Okay, Shashwat, check your answer again. Shubhangi, check your answer again. N is there 3 times. D is there how many times? Only 2 times. E is there how many times? 1, 2, 3, 4, 4 times. P is there how many times? Only once, I guess. Okay. And P and C is there only once. Tell me. I think I've written it correctly. Okay. Tell me. Okay. Ahir, what are you writing? This is the answer of
Question
number
number 2.
2. Oh,
Yes,
acha.
sir.
But number 2 is a proof problem. Oh, acha. Wait. No, I think there is a slight mistake in number 2. I've got a different answer. Okay. So I is once, N is thrice. 1, 2, 3. D is twice. D is twice. E is there 4 times. 1, 2, 3, 4. P is once. And I guess C is once. Okay. So everyone, over here, either you are going to select, so f of x will be equal to, either you are going to select 0 i's or 1 I. Okay. But like this, there are 3 more. I, P, C. So x plus x to the power 0 plus x to the power 1 whole cubed multiplied by. There are 3 n's. So either you will select 0 n's or 1 n or 2 n's or 3 n's. Next for D, either you will select 0D or 1D or 2D. Next for E, either you will select 0P or 0E or 1E or 2E or 3E or 4E. Tell me, has everyone understood? Tell me. Yeah, Shubhangi, right answer? Tell me, has everyone understood this part?
Sir, I had also sent.
Yes, I'm checking Joyatra. Wait a minute. Joyatra, check your answer again. Tell me, has everyone understood how I've created this function? Shashwato, is it clear? Shashwato, Abhipsha,
Yes,
Shamli,
sir.
Yes,
Samragni, is
sir.
it clear? Shwankit, is it clear? Tell me.
Yes, sir.
Shreyasi, have you understood? So over here we have got 1 plus x whole cube. That means 1 plus 3x square plus 3x cube. Sorry, it's 1 plus 3x plus 3x square plus x cubed multiplied by, over here there are 4 terms, so 1 minus x to the power 4 upon 1 minus x multiplied by 1 minus x cube upon 1 minus x multiplied by 1 minus x to the power 5 upon 1 minus x. Okay, so finally we are going to get over here we will get it would have been better if we it was whole cube na 6. Okay, so it will become 1 plus 3x plus 3x square plus x cube multiplied by 1 minus x to the power 4 into 1 minus x cube into 1 minus x to the power 5 multiplied by 1 minus x whole to the power minus 3. So over here we need the coefficient of, tell me, how many letters we need to select? 5. Now here we need the coefficient of x to the power 5. We need the coefficient of x to the power 5. Okay, so it's better if we multiply these two, these first. Okay, let us start multiplying. So this will give us 1 plus x whole cube multiplied by 1 minus x to the power 4 into 1 minus x cube. Okay, higher powers, we don't need higher powers more than 5. Okay, we don't need powers more than 5. So it will be 1 minus x to the power 3 minus x to the power 4 plus x to the power 7. We don't need it, so eliminate. Multiply by 1 minus x to the power 5 into 1 minus x whole to the power minus 3. Next, again let us multiply these two. So it will be 1 plus x whole cube multiplied by 1 minus x to the power 5. Okay, x to the power 5 is needed. Then minus x cube is needed. Minus x to the power 8 is not needed, so I won't write. Minus x to the power 4 is needed. Okay, apart from that, it is not needed. X to the power 9 is not needed. Multiplied by 1 minus x whole to the power minus 3. Again, let us multiply these two. So what have we got? 1 plus x whole cube. That is 1 plus x whole cube is 1 plus 3x plus 3x squared plus x cubed. Okay, so 1 into all these powers we require. 1 minus x to the power 5 minus x cube minus x to the power 4 we require. Then 3x into 1, 3x is required plus 3x. Okay, then x into x to the power 5 is not needed. So then 3x into x cubed is needed. That will be plus 3x into minus x cubed minus 3x to the power 4. Okay, then plus 3x into minus x to the power 4. So minus 3x to the power 5. Okay, then plus 3x square into 1 is required. Then plus 3x square into x to the power 5 not required. Plus 3x square into minus x cube. So minus 3x to the power 5. Then 3x square into x to the power 4 not required. So won't write. Okay, then x cube into 1 is required. Then x cube into x to the power 5 not required. X cube into x cube not required. X cube into x to the power 4 not required. Only these are the coefficients that we require. 1 minus x whole to the power minus 3. So let us simplify this a little bit. It will be 1 plus 3x. Okay, then x square. X square term, let us see. 3x square. So only one of them is 3x square. So plus 3x square. Okay, then x cube minus x cube plus x cube. They will get cancelled. Wait, let me see. minus x cube plus x cube is gone. There's no other x cube term, I guess. Minus x to the power 4, minus 3x to the power 4, minus 4x to the power 4. So minus 4x to the power 4 and x minus x to the power 5, minus 3x to the power 5, minus 3x to the power 5. I guess minus 7x to the power 5. Into 1 minus x whole to the power minus 3. Okay. So let us see. When you open the brackets, you are going to get 1 into 1 minus x whole to the power minus 3 plus 3x into 1 minus x whole to the power minus 3 plus 3x square into 1 minus x whole to the power minus 3 minus 4x to the power 4 into 1 minus x whole to the power minus 3 minus 7x to the power 5 into 1 minus x whole to the power minus 3. Okay. Let's see. So over here, we need the coefficient of x to the power 5. That will be 3 plus 5 minus 1, C5. Plus 3 into, over here we need coefficient of x to the power 4. So 3 plus 4 minus 1, C4. Plus 3 into, we need the coefficient of x cube over here. So 3 plus 3 minus 1, C3. Minus 4 into, over here we need the coefficient of x. So 3 plus 1 minus 1, C1. Only coefficient of x is required. Okay. X cube is required. So x cube. Okay. And over here we need only 1. So minus 7. Let's see. Will we get our answer? The expression is quite huge. So 7C5 is 42. Plus 3 into 6C4. 3 plus 4, 7 minus 1. 6C4 is 15. Plus 5C3 is 10. Minus 4 into 3. That is 12. Minus 7. Let's see. 42 plus 15. 42 plus 45 is 87. Oh my. Okay, I think the answer is not coming.
7C5 is not 42. 21.
20. Acha, yes. 21 plus 45 will give us how much? 66. 66 plus 30, 96. 96 minus 19. That gives us 77. Yes, 77 is the correct answer. Okay. Tell me, has everyone understood? Yes or no? Hello. Has everyone understood?
Yes, sir.
Yes. Could it be done in a different way? I mean, there is one. We could have done by selection of identical objects also. This became a bit lengthy. Acha, if we would have done 1 minus x square upon 1 minus x whole cubed, would it be easier? 1 minus x square upon 1 minus x whole cubed upon, would it be easier? Okay, I'll see it later. Anyways, tell me, Adrija, is it clear?
Yes, sir.
And Joyatra, Shashwato, Oipsha, have you understood this problem?
Yes.
Shamli?
Yes,
Yes,
sir.
sir.
Okay, try out number 2.
Yes, sir.
Let's see. Okay, yes, I hear your answer is correct. Yeah, Shubhankit, this is the answer of number 2, which you sent just now.
Yes, sir.
Yes, it is correct. Okay, should I start, everyone?
No, sir, please wait.
Okay, solve quickly. We need to find out the number of ways to select 5 letters from 5 A's, 4 B's, 3 C's. Shubhangi, check your answer again. Samragni, there's a slight mistake. Shubhangi, now it is correct. Abhipsha, check your answer again. Okay, Pallavi, did you understand number 1? Tell me.
Yes, sir.
Okay. Madhujo, did you understand?
Yes, sir.
Okay. Adrito, check number 2. Adrija, there is a slight mistake. Sanaya, did you understand number 1? Shamali, your answer is correct. Abhipsha, now it is correct. Arif, your answer is correct. Adrija, your answer is correct. Joyatra, your answer is correct. Ronak, your answer is correct. So let us start, everyone. There are 5 A's, 4 B's, 3 C's. Rashishwari, there's a slight mistake. 5 A's, 4 B's, 3 C's. So either you are going to select 0A or 1A or 2A or up to 5 A's. Or then either you will select 0 B's or 1 B's or 4 B's. Then either you will select 0 C's. Oh, why I have written B, X. 0, 0 C, 1 C, or 3 C's. Yes, Madhurjo, right answer. Okay, let us simplify. This will be 1 minus x to the power 6 upon 1 minus x multiplied by 1 minus x to the power 5 upon 1 minus x multiplied by 1 minus x to the power 4 upon 1 minus x. Okay, over here we need the coefficient of, tell me everyone. Over here we need the coefficient of,
X to the power 5.
again x to the power 5, 1 minus x or to the power minus 3. And here we need the coefficient of x to the power 5. Okay, so let us simplify. This will be equal to, let us first of all multiply. Higher powers will be eliminated. So 1 minus x to the power 5 minus x to the power 6, no needed, not needed. And then plus x to the power 11 is also not needed. Next, multiplied by 1 minus x to the power 4 into 1 minus x whole to the power minus 3. Let us multiply. Okay, 1 minus x to the power 4 minus x to the power 5. Again, x to the power 9 is not needed. Okay, so this was simple. It will be 1 minus x whole to the power minus 3 minus x to the power 4 into 1 minus x whole to the power minus 3 minus x to the power 5 into 1 minus x whole to the power minus 3. Here we need the coefficient of x to the power 3, right? Sorry, coefficient of x to the power 5. In the next one, we need coefficient of x. Over here, we need only one. Okay, so over here, coefficient of x to the power 5 will be equal to 3 plus 5 minus 1, C5, minus over here it will be 3 plus 1 minus 1, C1, minus 1. This will give us how much? It was 7 C5 21 minus 3 minus 1, that is 17. 17 is the correct answer. Tell me, is it clear to everyone? Ritam, have you understood? Ritam, Pratyay,
Yes, sir.
Shreyasi, Shanaya, Shashwato, are you getting?
Yes, sir.
Yes, sir.
Okay. Pallavi, did you understand?
Yes, sir.
Okay. Everyone try this out. This is also a good problem. Prove that 72
Yes, sir.
C30. Yes, I'm actually looking at your proof. Actually, uh, over there, I just have one problem. You have used Wilson's theorem, right? I know.
Yes, sir.
Okay. But the thing is, when you are dividing, you also have to show that, okay, just give me 1 minute. In case of division, okay, I absolutely got it. Yes, it is correct, correct. Absolutely correct. Okay.
So we can divide.
No, actually, the thing is, you didn't actually divide it. Okay. Means the thing is, what you used is if A is congruent to B mod M
Yes, sir.
and C is also congruent to B mod M, then you divide it. So it's fine.
Yes, sir.
Okay, because they belong to the same congruent classes, same
Same
modular class.
congruent classes. Yes, sir.
Yes. Then you divide. So it's fine. Okay, I was checking whether the remainders you are getting is same or different. But in your case, it is same only.
Same. Yes, sir.
Okay. So everyone, should I start? So here, this can also be proved without congruent modulo. Okay, can you think of it?
Yes, sir. I will do
Okay.
it. Like Wilson theorem was easier, so
Easy. Think a little bit
yes, sir.
without. Okay, let us start. So everyone pay attention. This is number 3. I hope you people remember NCR plus NCR plus 1 is equal to N plus 1 CR plus 1. Right? You people remember? Okay. So everyone, in order to get 72C36, okay, I'm going to break 72C36. So can I write 72C36 plus 72C37 is equal to 73C37? Tell me. So this implies 72C36 is nothing but 73C37 minus 72C37. Tell me, are you people getting? If you people didn't understand, you can ask me. Tell me, Avisha, are you getting? Avisha, Abhigyan, are you getting?
Yes, sir.
Abhigyan,
Yes,
did
sir.
you understand the previous ones?
Yes, sir.
Okay. Shamili, are you getting?
Yes, sir.
Okay. So 72C36 is equal to 73C37 minus 72C37. Okay. We can further move on. Okay. So everyone, this will give us, again, let us break 70. So this is divisible by 73. Okay. Let us keep on breaking. Can I further write it as 73C37 minus 73C38 minus 72C38? Tell me, are you people understanding? I have broken 72C37 now. Just like 72C36 is equal to 73C37 minus 72C37, I have written 72C37 as 73C38 minus 72C38. Tell me, are you getting? Yes or no? Okay, next. I'll keep on breaking it. Okay, after some steps, what are we getting? We'll get 73C37 minus 73C38 plus 73C39 minus 73C40 dot up until plus 73C37. Okay, sorry, 73C73. Okay. So everyone, over here, all these numbers up to 73C72, all these numbers are divisible by 73. Right, tell me everyone. Up up until this one is divisible by 73. Okay. Taking 73C73 to the left hand side, what are we getting? This implies 72C36 minus 1 is equal to this whole expression, which is divisible by 73. Is it clear to everyone?
Yes, sir.
Anyone having any doubt, you can ask me now. Tell me, Shashwato, Shavankit, are the people getting?
Hmm.
Yes, sir, clear.
Adrija, Adrito, Madhurjo, Anvesha, are the people getting?
Yes,
Yes,
sir.
sir.
Okay. Ritam, Pratyay, Shanaya, Samragni, is it clear?
Yes, sir. Yes, sir.
Hence
Yes,
proved.
sir. Yes, sir.
Hence proved. Okay. Next, our next topic is numerically greatest term. Okay, everyone. Our next topic is numerically greatest term. So I'll give you an example.
Sir,
Yes, tell me.
sir, could you please scroll a little up? I'm just writing the last part.
Yes. Numerically greatest term. Okay. So I'll give you an example. For example, if x equal to 1 by 3, you need to find out the greatest term. Find the greatest term in the expansion of 1 plus 4x whole to the power 8. Okay. So let us start. How to solve? So everyone see. So what is 1 plus 4x whole to the power 8? 1 plus 4x whole to the power 8 is equal to 8c0 plus 8c1 into 4x plus 8c2 into 4x whole squared plus dot 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 plus 8c8 into 4x whole to the power 8. Okay, let us substitute 1 by 3. Okay, basically it will be 1 plus 4 by 3 whole to the power 8, which is 8c0 plus 8c1 into 4 by 3 plus 8c2 into 4 by 3 whole squared plus dot 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 plus 8c8 into 4 by 3 whole to the power 8. Okay. Achha, let us say let tr plus 1, let tr plus 1 be the greatest term. Okay. Let tr plus 1 be the greatest term. Okay. Then what I'm going to do is, then I'm going to write mod of tr plus 1. Okay. Then I'm going to solve this inequality. Mod of tr plus 1 is greater than or equal to mod of tr. Okay. Now, what is the benefit of this? I'll write it down. You'll understand. So let us simplify this. What is mod of tr plus 1? Basically, it will be 8cr. And since all the terms are positive, I'm not using mod. 8cr into 4x whole to the power r is greater than or equal to 8cr into 4x whole to the power r minus 1. Sorry, 8cr minus 1. Okay, let us simplify. Let us find out the value of r. So this will give us 8 factorial divided by r factorial into 8 minus r whole factorial into 4x whole to the power r. Achha, 4x whole to the power r, these two will get cancelled. Into 4x so means 4 by 3 is greater than or equal to 8 factorial divided by r minus 1 whole factorial into 9 minus r whole factorial into 9 minus r whole factorial. So from both sides 8 factorial gets cancelled.
So
R
that will
minus
be
1
r
whole
minus
factorial.
1 factorial.
Yes, factorial. R minus 1 whole factorial, this will go by r. Okay. 8 minus r whole factorial, this will go by 9 minus r. Okay. So let us simplify. What are we getting? 9 minus r upon r is greater than or equal to 3 by 4. So everyone, 36 minus 4r is greater than or equal to 3r. So from here we are getting r is less than or equal to 36 by 7. Okay. Next. So if r is less than or equal to 36 by 7, what is the closest integral value? Tell me the maximum possible integral value of this r.
5.
Maximum integral value of r is equal to 5.
Sir, can you scroll up a bit?
Yes.
Sir, where are we getting 3 from?
4 by
4 by
3? 4 by 3.
yes.
I've taken 3 by 4 to the right.
I mean, no. I'm asking where did I get 4 by 3? I mean, I am getting 4, but I'm not getting divided by 3.
X was 1 by 3, na? So when you substitute x over
Oh,
here, you are getting 4 by 3.
okay. You replaced x.
Yes, yes. Okay. Next, maximum integral value of r is equal to 5. Okay, maximum integral value of r is equal to 5. Okay. Achha, over here, what I mean, why did I solve this inequality and what does it means? See, here it means Here it means that for r less than or equal to 5, okay, for r less than or equal to 5, it always satisfies. It always satisfies the inequality. Satisfies the inequality tr plus 1 is greater than or equal to tr. Okay. So putting r equal to 0, what are we getting? Putting r equal to 0, we get r equal to 0, 1, 2, 3, 4, 5. We can substitute. What are we get? What are we getting? We get T2 is greater than or equal to T1. T3 is greater than or equal to T2. T4 is greater than or equal to T3. T5 is greater than or equal to T4. And T6 is greater than or equal to T5. If I combine all this inequality, okay, from all of the above inequalities, which one is the greatest? From the
T6.
above inequalities, we can conclude from the above inequalities, T6 is the greatest. Are getting everyone how we can find out the numerically greatest term? T6 is the greatest. Therefore, what is T6? T6 is equal to 8C5 into 4 by 3 whole to the power 5. Tell me, is it clear to everyone? Hello. Has everyone understood? Tell me, Abhigyan, Aibsha, Arif, is it clear?
Yes, sir.
Okay.
Yes, sir.
Okay, so everyone, let us do some problems. Question number 4. Find numerically greatest term. Numerically greatest term for 3 minus 2x whole to the power 9. For part 1, 3 minus 2x whole to the power 9 if x equal to 1. Part 2, 2 plus 3x by 8 whole to the power 10. No. Find numerically greatest term for 3 minus 2x whole to the power 9 for x equal to 1. Question number 5. The term T4 in the expansion of 2 plus 3x by 8 whole to the power 8 whole to the power 10 has the maximum numerical value. Has the maximum numerical value. Numerical value. Find the range of x. Find the range of x. Solve. Okay, should I start, everyone? Three minus two x whole to the power 9. Okay, everyone pay attention. Number 4. So 3 minus 2x whole to the power 9. Okay, compute mod of tr plus 1 greater than or equal to tr. Okay, let's see what are we getting. We are going to get mod of 9cr into 3 to the power 9 minus r into minus 2x whole to the power r is greater than or equal to mod of 9cr minus 1 3 to the power 10 minus r into minus 2x whole to the power r minus 1. Okay, putting x equal to 1. Putting x is equal to 1, what do we get? Mod of 9cr. Let us simplify. So since it is mod, nothing has to do with the negative sign. So 9 factorial divided by r factorial into 9 minus r whole factorial into 3 to the power 9 minus r into substituting so 2 to the power r is greater than or equal to 9 factorial divided by r minus 1 whole factorial into 10 minus r whole factorial 3 to the power 10 minus r into 2 to the power r minus 1. So everyone, these two will get cancelled. And over here, these two will get
Sir,
cancelled.
I sent.
I've sent it. Let's see. Yes, many people have sent it. Yes, Arif, your answer is correct. But actually, there is a twist. Oh, here, check your answer again. Rasheshwari, your answer is correct. Adrija, your answer is correct. Okay. So everyone, 9 factorial will get cancelled. Over here, these two will get cancelled by r. Over here, this will get cancelled by 10 minus r. So let us simplify. What are we getting? We are going to get 2 into 10 minus r must be greater than or equal to 3 into r. Let me see. 2 into 10 minus r and 3 into r. So over here we are getting 5r is less than or equal to what? 2 into 10 minus r, yes. 5r is less than or equal to 20. So r is less than or equal to 20 by 5, that is 4. So everyone, there is a very important thing to note. Whenever you get an integral value, r is less than or equal to 4. That means r can be less than 4 also. R can be equal to 4 also. Okay. So in this case, you have to check something. Okay, I'll tell you what you have to check. Putting r equal to 0, 1, 2, 3, 4. Okay. So tr plus 1 is greater than or equal to, in this inequality. Okay, what are you getting? You are going to get T2 is greater than T1. T3 is greater than or equal to T2. T4 is greater than or equal to T3. T5 is greater than or equal to T4. Okay, ultimately you have to find out T5. So what is T5? T5 is equal to 9C4 into 3 to the power 5 into 2 to the power 4. This is your correct answer. Okay, everyone. But since over here you have got an integral value, r is less than or equal to 4, a perfect integer over here. So you need to check. Okay, check whether, okay, check whether T5 by T4 is equal to 1 or not. Okay, so what is T5 by T4? 9C4 into 3 to the power 5 into 2 to the power 4 divided by 9C3 into 3 to the power 6 into 2 cubed. Okay, let us see whether they are equal or not. Okay, if they are equal, that means there are two numerically greatest terms. Are you people getting why are we checking it over here in this case? Since you have got r as a perfect integer. Okay, so what is 9C4? 9C4 is 9 factorial divided by 4 factorial into 5 factorial multiplied by 3 factorial into 6 factorial divided by 9 factorial multiplied by 2 by 3. Let's see, 9 factorial gets cancelled. 5 factorial, this will go by 6. 3 factorial, this will go by 4. Okay, so 6 by 4. 4th is the 12, 6 to the 12. Yes. So T5 and T4, they are both equal. Okay. Hence, there are two. This implies T4 is equal to T5. Okay. Hence, there are two greatest terms. There are two greatest terms. For r equal to 3 and 4. Is it clear to everyone? Hello. Has everyone understood?
Sir.
Tell me,
Yes.
Abhigyan or Ipsha, Shashwato, is it clear? Arif, is
Yes,
it
sir.
clear?
Yes, sir.
Yes, sir.
Okay. Anvesha, have you understood? Anvesha, Madhurjo, Pallavi, is it clear?
Yes, sir.
Okay. Shania, have you understood?
Yes, sir.
Okay. So whenever you see r is less than a perfect integer, okay, always check. Always check T5 with its preceding term. Okay, quickly solve everyone. You need to find out the term T4 in the expansion. Quickly. Quickly, everyone, we have to move on.
Sir, will it be range of x or we'll get a single value of x?
Range. You'll get a range of x. Should I start, everyone?
So I got a single value.
Single value. Okay, let me start. Okay, so the term T4 in the expansion has the maximum numerical value. Okay, so over here, what does it mean that the term T4 has the maximum value? Number 5. So everyone, over here we need to ensure. Over here, we need to ensure T4 is greater than T3. T4 is greater than or equal to T3. Okay. But everyone, but it does not ensure us whether T5 is less than T4 or not. Are people getting? So over here we have to solve two inequalities. That is T4 must be greater than or equal to T5 and T4 must also be greater than or equal to T3. Is it clear to everyone? There are three inequalities we need to solve. Okay, let us start. What is T3? T3 is 10C2 into 2 to the power 8 into 3x by 8 whole squared is less than or equal to 10C3 into 2 to the power 7 into 3x by 8 whole cubed is greater than or equal to 10C4 into 2 to the power 6 into 3x by 8 whole to the power 4. Okay. So on simplification, let us simplify. When you simplify these two, okay, let us simplify these two first. 10C3 and 10C2. Of course, 10C3 will be greater. Okay, let's see. So 10C2 is 10 into 9 by 2, 45. 45 and 45 into 2 to the power 8. 45 into 2 to the power 8 is less than or equal to 10C3 is
120.
120. 120 into 2 to the power 7 into 3x by 3. Okay. So from here, 3x by 3, actually mod, you have to use mod. Mod of 3x by 3 must be greater than or equal to 45 by 120. Sorry, 3x by 8. 45 by 120 into 45 by 120 into 2. Okay, let's do some cancellation. 30 times 3, 30 times 4. Okay, so from here, mod of x is greater than or equal to 3 by 4 into 8 by 3. That is, mod of x is greater than or equal to 2. So what does it imply? It implies x belongs to minus infinity comma minus 2 union 2 comma infinity. Tell me, Shwankit, are you getting? This is one of the inequality you'll get. This is one of the inequality you'll get. Okay. Next, there is another inequality we have to solve. That is this one. Okay, 10C3 and 10C4. So somebody tell me what is the value of 10C4? What is the value of 10C4? Is it 126 somehow? Just tell me. 10C3 is 120. We can do some cancellation for better results. Okay. So mod of 3x by 8 must be less than or equal to. In this case, it is coming less than or equal to. Mod of 3x by 8 is less than or equal to 10C3 by 10C4. 10c3 by 10c4 into 2. Okay. Which is less than or equal to 10c3 is 10 into 120 divided by 10 into 9 into 8 into 7 multiplied by 1 into 2 into 3 into 4.
210.
How much? 210. Sure. I think we can do some cancellation over here also. 30 times 3, 30 times 4. Over here, 3 8s are 24. 24 gone. Okay. So mod x is less than or equal to 4 into 2, 8. 8 by 7 multiplied by 8 by 3. Yes. So mod x is coming as less than or equal to 64 by 21. Okay, this is equation 2. This is inequality 2, inequality 1. Okay. Further, we can write it as x belongs to minus 64 by 21. Can someone tell me the intersection? Tell me. What is the intersection of 1 and 2? Intersection of 1 and 2. Can someone tell me? Tell me. After this, you people are capable of taking the intersection. Tell me. Anyone?
-2 and 2, I guess.
What?
Minus
No.
64 by 21 comma 2 in close bracket union 2 comma 64 by 21.
Very good. Minus 64 by 21. Right. What happened, everyone? You people got tired. The class has just started. And you people seem tired. Today's class will end in the morning 5 o'clock. Okay. Hello, can everyone hear me? Abhigyan,
Yes, sir.
Aksha,
Yes, sir.
Adrija.
Yes, sir.
Okay. Okay. I hope you people had your dinner properly.
Yes, sir.
Today was anyways Wednesday. Okay. Next. So I hope you people have understood how to find out the numerically greatest term.
Hello, sir.
Yeah, Shumankar, tell me.
Can we do this by differentiating and equating in zero?
Differentiating? Why? Cannot understand. I mean, how and why?
So if we take the T4 and then means using maximum minima like that.
Ma maximum minima. What? Why will we take maximum minima over here? Cannot understand.
If we differentiate T4,
Okay. First of all, P4 is just an expression in 2 plus 3x by 8 whole to the power 10. So if you find out T4, okay, T4 will be an exact value. Are you getting?
yes, sir.
Okay. So what are you getting for T4? Tell me.
We will get 10c3 into 2 to the power 7 into 3 by 8 whole cube into x cube.
Okay, let's see. Ten C3 into 2 to the power 7 into 3 by 3x by 8 whole to the power
3.
3. Okay. But over here, we have to compare with T3 and T5. Are you getting? So how come we can use maximum minima over here? Wait, I'm missing out on something. Acha, over here, what is the function over? Tell me. I mean, this is 2 plus 3x by 8 whole to the power 10. Okay. So over here, what is the variable? Tell me, Shwankit. X is a variable or R is a variable?
X is a variable.
No, x is actually x is just fixed over here. Over here, r is a variable in this expansion. For r equal to 1, you will get some other value. For r equal to 2, you will get some other value.
Expansion, but in T4, R is given as 3.
In T4, acha, so you have to compare, right? Tell me. See, in T4, this is actually a cubic. Can you understand?
Yes, sir.
Okay, what will be the graph of the cubic? Tell me. Can you tell me what is the graph of this cubic? Tell me. Tell me, Shavankit.
Sir, means
Actually, wait, wait, wait.
like
I'll make it clear to you. Okay. Basically, this is k into x cube, right? Can you understand? X cube is multiplied to a constant. Yes or no?
yes, sir.
So, what kind of a graph you'll get? This is the graph, right?
Yes,
Yes or
sir.
no? So, how are you getting maxima minima over here? Tell me. Now, why maxima and minima won't work over here? Tell me. This is another way to understand why maxima minima is not working over here. Because try to understand, you are comparing this expression with different values of x only. Are you getting? Not with different number of terms. But the question clearly says that you have to find out numerically greatest term in the expansion of this expression. Understood? Means for a
Yes,
particular value of x, you have to find out which term will be the greatest. Are you getting, Shwankit?
yes, sir.
Why your
Oh,
why maxima
understood.
minima doesn't works over here? You have to compare with respect to the terms, not with respect to different values of x. Okay?
Yes, understood.
Okay. So next, our next topic is Taylor and Maclaurin series. Okay, this is also very important. If a question comes on power series in the exam, you know Taylor and Maclaurin's, you know power series, then you will only be able to solve. Okay. Otherwise, if you don't know, you will stay puzzled. Okay. So everyone pay attention. What is Taylor and Maclaurin series? Okay, basically, let us say a function is given to us. Okay. Suppose a function f has an infinite power series, has an infinite power series representation at a particular point C. Okay. At a particular point C, it has an infinite power representation. Okay. That is f of x is equal to summation of n equal to 1 to infinity an x minus c whole to the power n. Okay. Let us call this equation 1. Okay. So over here you can understand everyone that we can find out the nth derivative of f of x. Nth order derivative of f of x exists. Right? Can you people understand? If you are unable to understand, you can ask me. Tell me. Oipsha, Abhigyan, are you people able to understand? Since the power of x is n over here, then its nth order derivative exists? Yes or no? Tell me. We can differentiate it 10 times? Yes or no? Tell me. Oipsha, Abhigyan, Shamili, Shubhangi, Shashwato, Anvesha, are you people getting? Shanaya?
Can you explain once?
Yes. So basically, this particular expression, f of x, can be written in terms of a n x to the power n plus some a n minus 1 x to the power n minus 1. Like this, it goes on. Tell me.
Yes, sir.
So can you differentiate it n times? Yes or
Yes.
no? We can differentiate it n times. So that's
Yes,
what I
sir.
have written. That nth
Okay,
order
sir.
derivative of f of x exists. Okay.
Okay, sir.
So what is f of x? Now over here, I'm going to find out an. Okay. Now we'll find an.
So what is the C?
C is a point, an arbitrary point on the real number axis. Okay, real axis. So here, what is
Any random number?
any random number? Okay.
Okay, sir.
So f of x will be equal to a0 plus a1 into x minus c plus a2 into x minus c whole squared plus dot 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 plus an into x minus c whole to the power n. Okay, everyone. Acha, what is now? My task is to find out an. Okay, everyone. So everyone, what is f dash x? F dash x will be equal to a1 plus 2a2 x minus c plus 3a3 x minus c whole squared. If you are unable to understand, you can ask me, everyone. Tell me.
Sir,
Plus
C is constant.
c is just a constant, an arbitrary constant on the real axis. It can be 1, 2, 3, any real number. Okay.
Okay, sir.
Okay. Tell me, are you people getting? I differentiated it once.
So that will be n minus 1.
N minus 1. Tell me, Ahir, Shwankit,
Sir.
Ritam, Pratyay, Ronak, Shashwato, Shreyasi, Shubhangi, are you people getting?
Yes, sir.
Joyatra,
Yes, sir.
Pallavi, are you getting? Tell me. Hello, Pallavi, are you getting?
Yes, sir.
Okay. Let us differentiate it once more. F double dash x will be equal to a1 is also gone. We'll get 2 into 1 into a2 plus 3 into 2 into 1 into a3 into x minus c. Okay. Plus dot 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 dot. Sorry, 3 into 2 into 1 a3 only. A3 3 into 2 into 1 into a3 into x minus c. X minus c. Yes. Plus dot 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 plus n into n minus 1 into an into x minus c whole to the power n minus 2. Okay. Let us differentiate it once more. Okay, f triple 3x will be equal to 2 into 1 gone. So 3 into 2 into 1 a3 plus 4 into 3 into 1 2 into 1 a4 plus dot 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 plus n into n minus 1 into n minus 2 into an x minus c whole to the power n minus 3. Okay, dot 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 dot. Differentiating it n times. Fn x. Adrito, are you getting? Tell me.
Yes,
So what
sir.
will, if I keep on differentiating it like this, okay, what will I get? Fn x? All of them will get cancelled, right? Only the last term will remain. Yes or no? Tell me, everyone. And what will be the last term? N factorial into an. Tell me. Are you people getting? Yes or no? fn x will be equal to n into n minus 1 into n minus 2 up to dot 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 an, yes or no? And after that there will be other terms also, means more than n. You might get n plus 1 whole factorial into an plus 1 into x minus c, and dot 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 dot, many more things you'll get, right? But all of them will contain a factor x minus c. So everyone, what will be f nth derivative of f at c? It will be n factorial into an, yes or no? Okay, this is an important part. Okay, to understand power series, it's an important.
So from where you got an plus 1?
It's an infinite series, right? After that, an plus 1 will also come, isn't it? Hmm? It's an infinite series. Or if are you getting or no?
Sir, so it will continue till infinity.
Infinity. Yes, it is written though. From n equal to 1 to infinity. It is not stopping at n. It's not a finite series.
Okay, sir.
Are you getting? I am generalizing it in terms of n. So the nth derivative of f of n at c will be equal to n factorial into an. Tell me, Shubhankit, are you getting?
Yes, sir.
Okay. So putting an in equation 1, what do we get? We get f of x will be equal to summation of n equal to 0 to infinity an into x minus c whole to the power n, which is equal to summation of n equal to 0 to infinity nth derivative of f at c divided by n factorial into x minus c whole to the power n. Okay, so everyone, this is the power series for any polynomial. And why the power series is required, everyone? Okay, power series is required to convert any transcendental function. Transcendental function means any non-polynomial function into a polynomial function. Okay, any non-polynomial function like trigonometric function or some exponential function into a polynomial function. Okay, to find out its approximate value at a particular value of x. Okay,
So it will be from n equal to 0 or n equal to 1?
n equal to, wait a minute, I took n equal to 1, but it should be n equal to 0. Okay, everyone, change it to n equal to 0. Starts with a0. Ah, yes. Change to n equal to 0 in the beginning. Okay, similar type of series. Okay, similar type of series you will, not similar, means a similar kind of transformation. You will learn it in engineering known as Fourier transformation. Okay, if you have heard of it, I don't know. Okay, Fourier transformation. This is also very important, but it is not there in JE. Okay, not currently not required. Okay, Taylor and Maclaurin series is also not required, but to understand some good problems in calculus and binomial series, okay, this transformation is required. Okay, f of x. So everyone, let us expand and see what are we getting in Taylor series. So f of x will be equal to f of c plus f dash c by 1 factorial into x minus c plus f double dash c by 2 factorial into x minus c whole square plus dot 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 plus up to infinity. Okay, so this is what f of x is. And you can expand any series, everyone, any series, okay, using this Taylor series. Okay, but everyone, this Taylor series we don't require, okay, once you understand Maclaurin series, okay, you won't require Taylor series. Okay, everyone. So for Maclaurin series, what will happen? So for Maclaurin series, okay, what will happen? Put C is equal to 0. What do we get? Since C is a real number, we can put C equal to 0. We'll get f of x is equal to f of 0 plus f dash 0 by 1 factorial plus f double dash 0 by 2 factorial, f dash 0 by 1 factorial into x plus f double dash 0 into by 2 factorial into x square plus f triple dash 0 by 3 factorial into x cube plus dot 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 plus up to infinity. Okay, this is the expansion of any series. Okay, and generally I'm going to use Maclaurin series only whenever I want to expand a non-polynomial function. Okay, I'm going to use Maclaurin series more frequently. Okay. Next. So let us do some expansion. Okay. For example, let us see f of x is equal to e to the power x. Okay, I'll expand f of x is equal to e to the power x. Okay, everyone, let us start. So we need to find out Maclaurin series. Okay, I mean expand using Maclaurin series. Expand using Maclaurin series. Okay, Taylor and Maclaurin series, you'll learn it in engineering also. Okay, more deeply. Currently, whatever is required, I'm discussing. So everyone pay attention. So what do we require? We require f0, f dash 0, f double dash 0, and so on. So everyone, what is f of x? F of x is equal to e to the power x. What is f dash x? E to the power x only. Right, you people know, right? F dash x is equal to e to the power x. F double dash x is also equal to e to the power x. You people know, right? Tell me. And
Sir.
nth derivative of x, f of x, is also equal to e to the power x. Tell me f of 0 is equal to 1. F dash 0 is also equal to 1. F double dash 0 is also equal to 1. Dot 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 dot. Nth derivative of f at 0 is also equal to 1. Okay, so let us expand. So everyone, what is f of x? So f of x will be equal to summation of n equal to 0 to infinity. It was nth derivative of f at 0 upon n factorial, nth derivative of f at 0 upon n factorial into x to the power n. Right, x to the power n only, right? Okay, so let us start. This will be equal to fn 0. So for n equal to 0, it will be f of 0. F of 0 is equal to 1. 1 by 0 factorial. So 1 plus f dash 0, n equal to 1. So it will be equal to 1 by 1 factorial into x. So 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus dot 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 up to infinity. Is it clear, everyone? So this is the expansion of e to the power x. Okay. See, right hand side is a
His
polynomial.
screen is frozen.
Frozen.
Yes, sir.
For others, it is frozen.
No, sir.
It's fine. Okay.
Yes, sir.
Okay. I hear now it is okay.
Yes, sir.
Okay. So has everyone understood expansion of e to the power x? It's important. It is required in calculus also. Remember this series so that you don't need to derive over and over again. E to the power x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus up to infinity. Similarly, if I ask you, what is e to the power minus x, everyone? What is e to the power minus x? 1 minus x upon 1 factorial plus x square by 2 factorial minus x cube by 3 factorial dot up to infinity. Okay, alternately positive, negative, positive. Next, after that, we have log series also. Log series. Okay, this is only valid. Logarithm series is only valid for x belongs to open minus 1 to closed 1. Okay, that is ln 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 plus x to the power 5 by 5 dot up to infinity. Okay, over here there is no factorial in the denominator. Okay, if you want to expand, you want to prove it, you can prove it using Maclaurin series. Right? You people are capable of proving it now? Tell me. Will you people be able to prove? Similarly, if I want to write down ln 1 minus x instead of x, replace it by minus x. It will be minus x square by 2 minus x cube by 3 minus x power 4 by 4 dot up to infinity. Tell me. Anyone having any doubt? These are very important power series which you people should remember. Tell me. Oipsha, Abhigyan, Ahir, Adrija, Anvesha, everyone understood? Joytra,
Yes, sir.
Yes.
Ritam,
Yes, sir.
Protay, Shania, Samragni,
Yes,
is it
sir.
clear?
Yes, sir.
Yes, sir.
Madhurjo, Shreyasi, Shumankit, is it
Yes, sir.
clear?
Yes,
Yes,
sir,
sir.
clear.
Shamili, have you understood?
Yes, sir.
Okay. So if you people have understood, I'll give you an example how to solve. Okay. For example, okay, what kind of questions you can be asked? Find the value of find the value of 1 by 2 into 3 plus 1 by 4 into 5 plus 1 by 6 into 7 plus dot up to infinity. Okay. So let us start. So what you do is step 1, you take s is equal to the expression. Let s is equal to this expression. Okay. Are you people able to understand that it can be converted into telescopic? Tell me. Can we write it as, see, the difference is 1 in the denominator, right? We have
Yes,
done
sir.
it so many times. 3 minus 2 by 2 into 3 plus 5 minus 4 by 4 into 5 plus 7 minus 6 by 6 into 7
Sir, could you
plus
scroll
dot
up a
up to infinity. Or if did you understand how to solve, how to convert
Yes, sir.
every polynomial into power series? Okay, next. So everyone, we can write it as 1 by 2 minus 1 by 3 plus 1 by 4 minus 1 by 5 plus 1 by 6 minus 1 by 7 dot infinity. This is step 1. Step 2, You need to identify whether what kind of series it is. What do you think? Is it log or exponential? Tell me. Identify.
Log.
Exactly. It is log. Why it is log, Adrija?
Because of in the denominator there is no factorial.
Exactly. Very good. Identify whether it is log or exponential. Okay. So since you have understood that it is log, okay. So what you do is you write down what is and the numerators are all one. Okay, everyone. How are we going to get one in the numerator? What shall we substitute?
0.
If you substitute zero, it will be 0
1,
by 2, no?
1,
1
1.
only,
1. 1.
right? So everyone, what is ln 1 plus 1? Ln 1 plus 1 will be equal to 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 dot 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 up to infinity. You can compare, everyone. You can compare these two, right? From here to here, it is minus s, right? Everyone, tell me. If you
Yes,
take
sir.
minus common, okay, it is half minus 1 by 3 plus 1 by 4 dot 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 up to infinity. This is nothing but s. So ln2 is equal to 1 minus s. So everyone, what is the sum of the series? It is equal to 1 minus
Minus
ln2.
ln2.
Is it clear to everyone what kind of questions will come and how you have to solve? Tell me, is there anyone having any doubt? You can ask me now. Tell me, Shreyasi, Shamali, Shubhangi, anyone having any doubt? Madhurjo,
No,
No,
sir.
sir.
No, sir.
Pallavi, you have any doubt?
No.
Apiksha, Abhigyan, Shashwato, everyone understood?
Yes, sir.
Yes,
Joyatra,
sir.
is it clear?
Yes, sir.
Okay, so we can do some problems. Question number, I don't know, 6. Question number 6. Let alpha beta, no, not this one. Simplify half minus 1 by 2 into 1 by 2 squared plus 1 by 3 into 1 by 2 cubed minus 1 by 4 into 1 by 2 to the power 4 dot 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 up to infinity. Question number 7. Let alpha beta, if alpha beta are the roots of if alpha beta are the roots of 3x square minus 6x plus 2 equals to 0, find 1 plus alpha by 2 plus alpha square by 2 factorial into 4 plus alpha cube by 3 factorial into 8 plus dot 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 plus up to infinity plus 1 plus beta by 2 plus beta square by 2 factorial plus beta square by 2 factorial into 4 beta square by 2 factorial into 4 plus beta cube by 3 factorial into 8 plus dot 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 plus up to infinity. Solve, quickly solve. Yes, Anvesha, Ahir, your answers are correct. Quickly solve so that we can move on. Adrija, your answer is correct. Samragni, your answer is correct. Everyone should be able to solve if you have understood power series. Yeah, Shamli, right answer. Shashwato, check your answer again. Abhiksha,
Sir,
right answer.
one question, is that a multiplication sign? I mean, question number 7, is that a multiplication sign or an addition sign?
Where?
In between the two brackets.
In between the two brackets, there is an addition sign.
Okay, sir.
Wait a minute. Let me check. Oh, it has to be multiplication. Sorry. It should be multiplication, everyone. Okay. Yes. Ahir, number 7 is correct. Madhurjo, check number 6. Joytra, your answer is correct, number 6. Adrito, number 6 is correct. Shubhangi, 6 is correct. Madhurjo, check number 6. Okay. Okay, in that case, we can start. Abhigyan, what happened? Abhigyan, Shubhankit, write your answers. Rasheshwari, also write your answers. Okay, let's start. So it is half minus 1 by 2 into 2 squared plus 1 by 3 into 2 cubed, dot, 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 dot. It goes on like this. Okay. So again, what do you think? What kind of series it is? Do you find factorial in the denominator? Tell me, everyone. Do you find factorial in the denominator? No, right? So it's
Yes,
again a
sir.
log series. Send. Let me see. Arif, both the answers are correct. Yes, Ronak, your answer is correct. Adrija, number 7 is correct. So of course it is a log series. Okay, you just need to understand what you have to substitute in place of x. That can be done using comparing. Okay, so ln 1 plus x. Just write it once. X minus x square by 2 plus x cube by 3 minus x power 4 by 4. If you write only up to this much and compare, what is the value of x? Comparing, we get x is equal to half. Okay, so s is equal to ln 1 plus half, which is ln 3 by 2. Done. It's very simple. Next, let us solve 7. Yes, Anvesha, number 7 is correct. Rasheshwari, also 6 is correct. Shavankit, 6 is correct. Okay, we can start with number 7. Again, now over here, there is a factorial, everyone. So what do you think this series is? This is a power exponential series, right? E to the power
Yes,
x.
sir.
Okay. So you can understand. So what you do is, once you write this, okay, you just write down what is e to the power x. E to the power x is equal to 1 plus x. So as soon as you write 1 plus x square by 2 plus x cube by 3, x square by 2 factorial, you will understand that x is equal to alpha by 2, right? From 1 and 2, you should be able to understand x is equal to alpha by 2. Okay, this implies 1 plus alpha by 2 plus alpha square by 2 factorial plus up to infinity is equal to alpha by 2. Okay. So basically, what do we need to find out? Okay. To find e to the power alpha by 2 into e to the power beta by 2, which is equal to e to the power alpha plus beta by 2. Now, what is sum of the roots? Sum of the roots is 2, which is equal to e to the power 2 by 2, which is e. E is the correct answer. I hope it is clear to everyone. Yes, Joyatra, your answer is correct. Okay. So everyone, one last topic of binomial. Your binomial is almost complete. That is approximation using binomial. Okay. Approximation using binomial. So everyone, what is 1 plus x whole to the power n? This approximation is required for other chapters. Okay. Other chapters also it is required. What is 1 plus x whole to the power n? This is approximately equal to 1 plus nx.
nx.
When x is very, very, very small. Very, very, very small. Okay. It is similar to 1 plus nx. Okay. So let us do some problems. Question number 8. Find cube root of 126. Means you have to find out the approximate value. Part 1. Part 2. Cube root of 28. Quickly send everyone. Very easy. You can give your answer quickly. Then Adrija, you're making a mistake. Wait, everyone, I'm solving this one. Pay attention. So basically, you need to convert it into 1 plus x. Okay, everyone. What you do is, and this approximation is only possible when x is very, very, very small. What you do is, you write down 1. You write down 1 plus 125 whole to the power 1 by 3. Okay. This can further be written as when you take 125 common, within brackets, you are going to get 1 plus 1 by 125. Now see x is very small, smaller than the previous one. So this can be helpful for better approximation. This will be equal to 5 common, within brackets 1 plus nx, that is 1 by 3 into 1 by 125. Are you people getting? This will be equal to 5 plus 1 by 375. You can say 5 by 375. Okay, this will give us 5 plus 1 by 75, which is equal to 376 by 75. Is it clear to everyone? Tell me.
Yes, sir.
Okay. Quickly
Yes.
send cube root of 28. In a similar way, solve cube root of 28. Yeah, Adrito, check your answer again. You are making a slight mistake. Adrija, Ahir, Pallavi, your answers are correct. Shashwato, your answer is correct. Arif, your answer is correct. Samragni, your answer is correct. Shwankit, your answer is correct. Ronak, your answer is correct. Anvesha, your answer is correct. Who is left? Avigyan, what happened? Are you there?
Yes, sir. They're trying.
Trying. Shubhangi, your answer is correct. Protya, what you have written? Why 3 into 1 minus? Why it is negative? You are making some mistake. Protya. Yes. Abhiksha, your answer is correct. Adrito, your answer is correct. I think Ritam is left. Protya is left.
Sir, my WhatsApp is not working. I can't send the answers.
Oh,
But I've got the answer.
okay. Yes, Jatra, your answer is correct. Yes. Protya, now your answer is correct. Okay, Abhigyan, what happened? This one is easy.
So it's almost done.
You have understood everything what in today's class, right?
Yes, sir.
So tell me the expansion of e to the power x. Yes, Shesi, your answer is correct. 1 plus 27 whole to the power 1 by 3. Taking 27 common, 3 outside. 1 plus 1 by 27 whole to the power 1 by 3, which will give us 3 into 1 plus nx. That is 1 by 3 into 27, which will give us 3 plus 1 by 27, which is 82 by 27. Okay. So this completes binomial theorem, everyone. Congratulations, everyone. Your binomial theorem is complete. Your
Thank you,
PNC
sir.
binomial. Yes. One more step closer to JEE mains and advanced.
Okay, sir.
Okay. Your PNC binomial test will be taken in the first week of March after everyone's exam ends. I think exam will be ended by 28th March. So keep practicing. This time, those who have not given the test for ellipse and hyperbola, okay, next test it is compulsory to give. Okay, like Pratyay, you have given it, right? Pratyay, did you give ellipse and hyperbola test? Give it, right? Okay, like Ritam, Joyatra, those who have not given it, PNC binomial test, you people have to give it. Is it clear?
So the
Yes, sir.
test is on which date?
First week of March, Sunday.
Okay, sir.
Okay, whichever date. Okay, the first week of
Sir,
March.
previous test, can I
Sir,
give it on March?
Huh?
The
Previous
ellipse
test.
hyperbola test? Yes, sir.
You can
sir,
give it.
apart from Sundays, like, can I give the exam on a different date?
Okay, let me know. Okay. Whenever you want to give, let me know. Okay.
Yes, sir.
Okay. So today I'll just give an introduction on complex numbers. Okay. I just give an introduction. Complex numbers. Yes, everyone, just I'll introduce complex numbers. Okay. You people know that natural number sets are a subset of whole numbers. Whole numbers are subset of integers. Integers are subset of rational numbers. Rational numbers are subset of real numbers. Real numbers are also a subset of complex numbers. Okay, everyone, remember. Next. So let us take a quadratic. Okay, I mean, how complex numbers were introduced, you will understand. Let us take a quadratic equation. X square plus 2x plus 2 equal to 0. Okay, so when you solve, what are you getting? X equal to minus 2 plus minus root over b square minus 4ac. That is 4 minus 8 by 2. This will give us minus 2 plus minus root over minus 4. Okay, so see, this is where the problem arises. Okay, that you are getting a negative number under the square root. This is where the problem arises. Okay, so that's why complex numbers was introduced. Okay, next, further it can be written as minus 2 plus minus. Even if you take out 4, you are going to get root 4 into root over minus 1. Okay, so now people started like people have to define this root over negative number. Okay, so this will be equal to minus 2 plus minus 2 into root over minus 1 was defined as iota divided by 2. This will be equal to minus 1 plus minus iota. Okay, so this is how, I mean, this is how we introduce complex numbers. Okay, in mathematics. Okay, by introducing square root of negative integers, negative numbers, where iota is equal to square root of minus 1 is the fundamental unit. Okay, everyone, it is the fundamental unit of complex numbers. It's the fundamental unit of complex numbers. Okay, next. Now in minus 1 plus iota, minus 1 is the real part, of the complex number, and coefficient of iota is the imaginary part. So in this case, minus 1 plus iota, what is the value of the imaginary part? Tell me, what is the imaginary part in this complex number? Can anyone tell me? Is imaginary part. Okay. Tell me, everyone, what is the imaginary part
Plus
in
1.
minus 1 plus 1? So every complex number can be written as Every complex number can be written as z is equal to x plus iota y, where x comma y belongs to real and x is the real part of z and y is the imaginary part of z. This is how it is denoted. Real part of z and imaginary part of z. Okay, argon diagram. Argon diagram or argon plane. Okay. Or you can say complex plane. Okay. So basically, real axis and a complex axis constitutes the
Sir,
argon
can
plane.
you scroll up a bit?
Yes, wait a minute. A real axis and a complex axis intersecting at 90 degree. Okay, just like in coordinate geometry. In coordinate geometry, two real number line intersecting at right angles constitutes a Cartesian plane. So similarly, a real axis and an imaginary axis intersecting at right angles constitute a complex plane or an argon plane. Okay, this is the real axis and this is the imaginary axis. Okay, next. So, I mean, how we can plot complex numbers on an argon plane? Okay, so if we want to plot, if we want to plot a minus 3 comma a equal to minus 3 plus iota on argon plane. Okay, just mark a minus 3 comma 1. Okay, so everyone, x equal to minus 3 and y equal to 1. This is a minus 3 comma 1. Okay, this is where the complex number lies. Is it clear to everyone? Tell me. If I want to mark 2 plus iota, 2 plus iota will be over here. Okay, everyone. This is 2 plus iota. This is x equal to 2, y equal to minus 1, 2 comma minus 1. Are you people getting? Tell me. How to mark, how to plot complex numbers on the number line, on the argon plane. Next, if z is equal to, if z is equal to a plus iota b, then a is purely real, a is purely real, iota is purely imaginary, iota is purely imaginary, and b is the imaginary part, b is just imaginary. Okay, these are some basic terms. And since a is purely real, since a is purely real, we can represent all real numbers We can represent all real numbers by putting b is equal to 0. Okay. Hence, real numbers are subset of complex numbers. Proper subset of complex numbers. Understood, everyone? Why real numbers are subsets of complex numbers? Tell me. Are people getting Abhipsha, Shwankit, Shubhangi, Shamili? Are people getting
Yes.
Joytara, Arif?
Yes, sir.
Okay. Pallavi, are you getting?
Yes, sir.
Okay. Next. Thus, if somewhere it is written Z is purely real, if somewhere it is written Z is purely real, then of course B is equal to 0. And somewhere it is written Z is purely imaginary. Z is purely, oh wait, real. Z is purely imaginary. Okay, then A is equal to 0. And if it is written Z is just imaginary, then we'll say B is not equal to 0. Okay. So remember, these are some terms that will be used when you solve problems. Okay. Note 0 plus iota 0 means 0 is purely real. Is purely real. Purely imaginary. But can I say it is imaginary? Tell me.
No, sir.
Can I say imaginary? No. But not imaginary. Okay. Remember. Next. Algebra of complex numbers. Algebra of complex numbers. Okay. Addition, subtraction, multiplication, and division. Addition, subtraction, multiplication, and division are carried out like ordinary algebra only. Like ordinary algebra only. Okay. Using iota as polynomial. Using iota as polynomial. Okay. Polynomial, or you can say polynomial in iota. Okay. For example, if I want to multiply 2 plus iota into 3 minus iota, okay, this will be equal to 6 minus 2 iota plus 3 iota minus I square. This will be equal to 6. I square is minus 1, so 6 plus 1 is 7. 7 plus iota. Okay. Next. Powers of iota. Powers of iota. Iota equal to root over minus 1. Okay. You see, I square is equal to minus 1. I cube is equal to minus iota. I to the power 4 is equal to 1. I to the power 5 is equal to iota. Okay, are you people able to see? What is the cyclicity? Tell me everyone, what is the cyclicity? Cyclicity is 4. So what is I to the power 4n? I to the power 4n is equal to 1. I to the power 4n plus 1 is equal to iota.
Iota.
I to the power 4n plus 2 is equal to minus 1. And I to the power 4n plus 3 is equal to minus iota. Remember. Okay. Next. Inequality in complex number is not defined. Inequality in complex number is not defined. It's not defined. Okay. For example, that is a plus iota b, okay, is greater than c plus iota d, has no meaning. Okay, has no meaning. How can a point be greater than another point? Okay, has no meaning. Okay, that is a point cannot be a point cannot be greater than another point. Okay. Equality in complex numbers. Equality of complex numbers. That is, if a plus iota b is equal to c plus iota d, what does it implies? It implies a equal to c and b equal to d. Okay, everyone. Achha, let us do two more problems. Okay. Find summation of r equal to 1 to 2026 I to the power r. Solve. R equal to 1 to 2026 I to the power r.
sir, I have sent the answer. Is it correct?
Yes, just give me 1 minute. Give me 1 minute, I'm checking. Pallavi, check your answer again. Adrija, check your answer again. Samrakni, right answer. Adrito, right answer. Rasheshwari, check your answer again. Anvesha, check your answer again. Pratyay, your answer is correct. Abhipsha, check your answer again. Ahir, check your answer again. Shumhangi, right answer. Shashwato, check your answer again. Abhigyan, check your answer again.
Sir, I also sent the second answer.
Okay, wait, I'm checking. Oh, wait a minute. Wait. I was checking the other way around. Yes. Shwankit, right answer. Ahir, your previous answer. Ahir, your answer is correct only. Okay. Acha, yes, wait. Shashwato, Abhipsha, your answers are correct. I was checking the other way around. Wait. Rasheshwari, Anvesha, your answers are correct. Adrito, your answer is correct. Okay. Adrija, Pallavi, your answers are correct. Abhigyan, your answer is correct. Madhujo, check your answer again. Ronak, your answer is correct. Joytra, your answer is correct. Okay. Everyone got iota -1? Tell me.
Yes, sir.
Yes, sir.
Okay. So I'm not solving. Everyone has got it. Anyone who couldn't solve? Okay, everyone has given the answer, I guess. Oh, Orif didn't give. Orif, Shamili, pay attention. Over here, iota plus iota square plus iota cube plus iota to the power 4 plus dot plus iota to the power 2020 plus 2021 plus iota to the power 2022 plus iota to the power 2023 plus iota to the power 2024. Okay, what is the sum? Tell me, Arif, Shamli. Sum up to 4 powers, consecutive powers, is equal to 0?
Yes, sir.
Right. So only the sum of the last two terms is required. Tell me, Shamli, Arif, are you getting? What happened? I don't know whether they are. Okay, last one. Question number 2, last one. Iota to the power 592 plus iota to the power 590 plus iota to the power 588 plus iota to the power 586 plus iota to the power 584. The whole thing is divided by iota to the power 582 plus iota to the power 580 plus iota to the power 578 plus iota to the power 576 plus iota to the power 574 plus 2. Solve. Last sum, everyone. Quickly solve. Yeah, Dhrito, in the end, you have to add also. See, it's plus 2 written. See, yes, now it is correct. Okay, everyone, see.
No, sir, wait. Doing.
Oh, solve. Last problem, everyone. Yes, Samragni, right answer. Samragni, right answer. Ronak, check your answer again. Rasheshwari, right answer. Okay. And Visha, at the end, you need to add 2 also. I think you are making a mistake. Ahir, right answer.
Yes,
Abhipsha
sir, I
also.
changed my answer.
Yes, Anvisha, right answer. Abhipsha, you added. Yes, right answer. Adrija, right answer. Ronak, right answer. Pallavi, right? Okay. So everyone, in the numerator, you take iota to the power 584 common. Within brackets, you are going to get iota to the power 8 plus iota to the power 6. Yes. Madhujo, right answer. Pratyay, your answer is correct. Plus iota to the power 4 plus iota square plus 1 upon take iota to the power 574 common, iota to the power 8 plus up to 1. Yes, Shubhangi, you forgot to add 2, I guess. This will be iota to the power 10 plus 2, which is minus 1 plus 2, which is 1. Okay. So everyone, we can keep it till now. Shashwato, you understood? Shashwato, Abhigyan, Shreyasi, is it clear? Or if have you people understood this one?
Yes, sir.
Yes, sir.
Okay. So I think everyone, we can keep it till now. Next class will again continue. This Friday night, I'm going to discuss ellipse and hyperbola paper. Okay. Thank you, everyone, and good night. I'll send everything in WhatsApp.
Good night, sir. Thank you so
Thank
Yes.
you,
much.
sir.
Thank you. Good night, everyone.
Sir,
Yes.
what was the optimum score for this ellipse paper?
Optimum score is 31 or 32. If you're getting above 30, 35, it's fine. Okay.
Yes, sir.
Okay. Good night, everyone.
Good night,
Bye.
sir. Thank you, sir.
Yes. Thank you.
Sir, for the PNCM binomial exam, can I give it later because my school annuals finish on 9th March?
You give it after 9th March. Okay.
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 Thank
Bye.
you. Good night, sir.
Good night.